Hello and welcome to the next installment of the construction videos for the C3Dt/C Cantilever printer. In this video we will actually be assembling the major parts of the printer. So in the previous videos we've put together the power unit, we've put together all three axes. In this video we're actually going to attach the axes to the central piece of this printer, which is the power unit. So we're going to attach them with some of the printed components and then these aluminum slats that will make for a very solid structure. And then at the end of the video we will be actually putting the controller board into the case itself and putting that together as well. We've got all the components. We have the bed carriage, which I bought this on eBay. Actually, I bought this directly from a website, and I'll put the link below. It's a very nice lightweight frame. I think I mentioned in the introduction, but the initial design had a 3D printed bed carriage, which was bulky and not the most stable of all. This one is lightweight and strong, so it makes for a stable bed. Using the heated bed with the silicone. Now, in one of the side videos, I actually showed how I put magnets in this bed, but that's not absolute. That's optional. It's an aluminum bed with a silicone heater on there that has the 12-volt power coming in, and then it has the thermistor coming out that will connect to the board. An additional motor for the extruder. That could be, this is a used motor, but it could be any motor. And since I'm actually using, for this printer, I'm using a remnant Titan extruder that I have, which is actually geared. So theoretically you could go with a smaller motor like a pancake motor, because the gears will add a lot of torque to the print. Let's get to it. I'm going to set some of this stuff aside for now. And the first thing that we are going to put together is the actual major center of this printer. And the major design consideration I made for this printer is that it is built around the PSU. If we look at the backbone of the printer, which is this part of the frame, it's a double extrusion. I have tapped ends in the end so I can actually attach this plate to it. The height corresponds with the PSU height. It's a little bit more, I guess, but I mean it's close enough to make this the back support, and then the y-axis will sit on top here. So that's the first thing that we're going to connect, and we're going to do that with this plastic connector. Now the way I designed this is it fits exactly to the universal screw. This is a universal PSU unit, so the screw holes should be always in the same place on these things. So there'll be an M5 screw going through here. Actually, I take it back, it's an M4, I believe. And then I will have two screws going through the back here that will expand this plastic inside the rail here. Alright, so I'll do that first. Alright, so I'm going to go like this. Alright, don't over tighten this, because these PSU units are made of like a soft aluminum. It's very easy to kill the thread on these. Careful there. Alright, and then this will go snap in here, and I will connect these. Okay, now this holds it in place. Additionally, there will be a corner plate that's connected to the y-axis, and the y-axis again is connected to the power unit at this side through this clip and this triangular clip. And then technically we can remove even this screw in here and connect it through an additional clip. But you know, this metal clip here will hold everything properly in place. Okay, so we're going to tap this over, and we are going to put on the y-axis. Now, the y-axis has the built-in end stop. So the y-axis, and very important when you put the y-axis together, which I forgot, is you have to put this a plate in here, which is one of the screw plates that will actually connect to this plate here. So make sure that this is in there before you do anything. Like I said, I actually had holes tapped in here that will fit these screws. So this will go. Let's see, let's get the right. All right. So let me add. You can plug in the wire now. It's very important that we use these shorter screws because I mentioned earlier the screw will actually go through here and it'll be sharing the space inside the rail with the belt. So if you make the screws if you get the screws that are too long, what will happen is you will actually crunch the belt into the frame, which is what you do not want to happen. Alright, so now this is where we're going to have to kind of line up right on this side. We are clicking it into there we go. So now it sits in the frame clip here. So this one that's connected to the actual power unit fits right in here. And then the other one that we are going to connect is we're going to take out this little screw here and reuse this hole to actually connect this part of the frame as well. Okay, that will be a M3. Now the one thing I did not properly account for yet, and we can do this later on, is to figure out where the bed needs to. This is using a longer axis than the one in the Instructable, so it's kind of sticking out further forward, and I'm pretty sure we can actually move the whole y-axis a little bit further backwards. So what we can do is in the end we can loosen this up and kind of push the axis to the back to figure out what the center of the bed is, because this will be moving the bed back and forth. Alright, so that takes care of the y-axis. The next thing that we can add is the z-axis. So now it kind of gets a little interesting here, because we can add the z-axis and then subsequently add the x-axis to here, which will be kind of working up in the air, but we'll do that anyways. Okay, we're going to actually lower the unit to not get this massive center of gravity way too high while putting this together. Now don't do this while it is connected to the board, because you're actually sending, when you turn this too fast, you send current back through the board and you can actually fry your stepper drivers. Alright, this guy is going to be attached like so, next to, and it will have this plate connected to it. I am using a bunch of these single connectors here. In the Instructable, I actually use the 3-hole ones. Both will work just fine. 3-hole ones might actually be a little bit more stable because you're dealing with one component as opposed to 3 loose components. Alright, so we are going to have 6 bolts going inside here, and then 4 bolts going up the rail here. So this guy is going to go up here, so we're going to insert this. Alright, so now we have the core of the printer together, but we have to get this angle proper. So I can use one of these, which we want to make sure that this is at a 90-degree angle, which it looks it is. So we're going to tighten this down, small increments. Alright, so here we go. So now we have Z and the Y axis. I'm going to hold off on the X axis until I've actually put the bed on. Let's see. I do want to know, so the actual hot end is about 4.5 centimeters in front of the rail, so 4.5 centimeters in front of that, and that's bed has to be able to move in both directions so that the hot end can reach both the start and the end of the bed. So I do believe I have to move this rail backwards because at its furthest point back here. Alright, we're just going to add the frame to the bed. Alright, so this is the bed carriage with, I've changed the spacing of the holes so that it will fit. Supposedly I have changed it. Yes, there we go. Alright, so we are going to, there we go. So we have the bed on. What we need to check for is, like I said, if I put this all the way back to the end stop, will I reach the edge of the bed here, which I will not. So we have to put the rail back, and we can actually put it back quite a bit because we've got a longer rail in this case. So I'm going to loosen up or there we go. So now the hot end will get past the bed here. Four and a half. And if I move the bed forward, it gets past there. So that's good. Smooth. All right. Excellent. We have the y-axis with the bed carriage, which is stable on here. We have the z-axis up here. So now at this point we can connect the x-axis as such. And again, we have to figure out, we have to reach the end of the bed with the hot end, which would be, well, this is literally as far as we can go. So we're going to click this in now. And this is going to be a bit challenging because we're dealing with click. There we go. So now the x-axis is clicked into we're reaching the end of the bed here, so that's good. All right. And go way back here. Reach this side of the bed. Kind of tighten this end stop in place. I'd say 12 millimeters, 10 millimeters distance between the tip of the hot end and the bed here. And this bed will be sitting on top of these little springs, so there's going to be, we can make that as much room as we like to, and we can level the bed that way. Okay, so we can screw the bed up a little again. Okay, so now here is the major frame. At this point we can start adding the bed, but before we do that, I would recommend that you actually do a quick visual check of whether or not the actual bed carriage is somewhat level. And the thing is that this is sitting on a plastic block, and there's, depending on how well it was printed, it might be a little crooked, but the nice thing is that it also gives so you can kind of tighten the screws to put the bed into level. And so what I'm looking for is that each of these corners, this one is 10.12 millimeters, this one is 12 millimeters, this one is 11.5. That's close enough because we can correct that with the screws in the bed itself, and this one is 12 again. So this is fairly level, but like if it's not level, you can kind of force the screws down, and it'll squish this plastic to, you know, it'll apply to where you want it to go. So try to get it as level as possible while the carriage is only on here, and then after that you can make corrections with the screws in the bed itself. So the bed, we have the silicon bed with the magnets picking up screws, and we're going to use, in this case I have a set, let me move this over here. Alright, I have a set of these screws. These are hex screws with the springs. Sometimes they come with the red rubber connectors that you can cut to size. Again, you can cut them to size to, you know, make sure your bed is level, but in this case I'm just going to use what I have, which is the screws and the actual little springs, the same springs that are being used, by the way, and the rails to keep the belt tensioned. It has these little nylon nuts, which are good because they keep tight, but the downside of it is it's not easy to adapt the screws, but we'll go with those too. Okay, so we're going to, the wire for the bed goes to the back. It'll be moving back like that. If you point it this way, it'll start banging into parts of the z-axis. the wiring points to the back. We are going to add the screws. Now, this is always a little. Again, I mentioned this earlier, but if you have your board hooked up, which we don't have yet, do not indiscriminately move back and forth your head or your bed, because that actually sends a power surge through the board, which can damage your stepper drivers. So there we have it. I'm going to tighten these till I hit the nylon and the nylon nut. So okay, so that takes care of the bed. Let's see what we're looking at here. 118, 117, and 118. Okay, so again, I'm going to do, this time I'm going to do a visual where I'm going to look at where the actual hot end ends up on the board. And since this uses auto leveling, it does not have to be 100% accurate, because auto leveling will actually adjust while printing. Alright, so I am pretty much above here. Alright, so I'm touching the bed now, so I'm going to take this a little. And there we go. This is fairly, yep, looks nice and level. That takes care of the bed. The next step, let's add the extruder motor to the printer. And like I've mentioned before, I will be using a Titan E3D Titan extruder that I had left over. I did have to order a Bowden connector because I was using my Titan extruder initially as a direct extrusion. A fairly heavy motor. Theoretically, since this is geared, and I believe the Titan is geared 3-to-1, you could possibly get away with a pancake extruder, but what the heck, it's what I have right now. Alright, so we're going to actually assemble the extruder. I'm going to temporarily remove the extruder clamp from the rail here so we can set this up on camera. Alright, what I am going to do is I'm going to actually set up the extruder on this side and have the motor on the other side. Now we want to be feeding in trying to find the most ergonomical way of feeding. Normally speaking, filament will come through the top, but since we're going Bowden, we want to do that either to the side, or we kind of want the Bowden tube to go out upwards. So we will be installing this as such. We're looking for connecting it like this. So now we have the extruder connected. We'll be feeding filament from the bottom. Bowden tube will come out through the top. be joined by this cable here. Okay, so we can add some of these clips here to actually keep the wiring in place. They're not really forcing anything tight, but that keeps everything nicely organized. Alright, so we can insert the little Bowden clip inside here, and we can add the Bowden later. I'm going to put this blue clip in here for now so I don't lose it. Alright, so that is that part. Now we have all the mechanics in place. Y-axis, Z-axis, X-axis. So at this point we can start working on the wiring, the actual hooking up of the controller board. Now, just to be clear, I'm not going to explain how this all works because we went through an entire video on wiring up the KFB. The next thing what we will do is we will basically just put this into the case and hook up all the wires, and then after that we will start testing some of the motion. Using the KFB 2.0 board, 3.0 would work too. It was designed with this case in mind, and actually let me make some room here. Slide this aside. All the wiring work will be happening on this side of the printer. This is the case that this will fit into. It was actually designed specifically to fit underneath here, and it's a close fit, but what I also try to do is make it such that at any given time I can release the screws and actually flip this over, so while the printer is running I can actually access some of the electronics, and that comes into play when you want to like fine-tune the little pot, the voltage going through the stepper motors. It's kind of nice to have access to the electronics. So even though this is a very compact design, I did try to keep in mind to make it manageable while it's running. The case itself almost speaks for itself. So there is an opening for the USB port on this side of the case. So that's where this fits in, and you kind of have to angle it properly and it'll go in there. And then you can just slide it in. And there are 4 screw receptacles for 6mm M3 screws. And so we will attach the board inside the case before we put in the wiring. Actually, I take that back. We're going to do something first because I've mentioned this before. This is an extremely tight fit, and this rail of electronics is actually very close to the wall here, so I'm going to attach those first to make sure I can even fit everything in here. So we're going to focus on this part of the board first, which are the power outputs for the fan, the heat bed, the hot end, and the power input. Okay, now the power input is coming from the PSU from the printer. We can add that one first, and in the video I explained how I applied these ferrules, but I kind of cut off most of the plastic part to hopefully make enough room to make this fit. Now, so in the initial video I messed this up and I hooked them up wrong, so I'm trying not to do this again. But it's very important that you connect the negative wire to the negative and the positive wire to the positive on the power input. Alright, so negative black goes into minus over here. And the plus 12 volts goes in here. And just as a dry run, I'm just going to see if I can actually get this to fit in here. That works. But like I said, it is a very tight fit. So let's see. I hope the same goes for the other. There we go. All right, the other output wires that are the 12 volt are the, this one goes to the extruder. So the thick wires here, these are the red wires that are insulated. These are the power output for the hot end. So they take a higher amperage and they go into the the heater 0. Now for the heater itself, there's no polarity, so it doesn't really matter how you hook these up. Important to note that for the wires coming from all the different components, I have this single entry inside the case here. This can get very, very tight. It's going to be somewhat challenging. What can help and what you can do possibly is to actually clip out this rail here, which will give you more room, but that will not secure the wires as well as trying to squeeze them all through this hole. So we're going to try to do it the right way first, and if I get absolutely stuck, I will make more room for more wires. Now we're dealing with several wires, but the two important wires here, the controller fan, they actually have to go into the board at the end here. We need to make sure that we can reach that. Alright, so I'm going to push this all the way through, and I'm going to now the controller fan has polarity, so the plus needs to go into the plus and the negative needs to go into the negative. The red wires, the thick ones here, are for the hot end. These are not, they don't care about polarity, so we can just add these in heater 0. Okay, so then the next one we have is the hot bed. The hot bed is over here, runs behind the axis, and it has the hot end and the thermistor on here. So we're going to get this cable through. Fits. Again, the hotbed 2 does not care about polarity, so it doesn't matter if it goes in plus or minus, but it has to go into the right receptacles. This is going to be by far the hardest part. We're going to have to get the board back in with all of these connected. And we are in. And all of those seem to be in place, so I'm going to add at least one screw in here to keep the board in place, which theoretically really is only what you need because the actual USB port clamps it in place, and so one screw would in fact keep the entire board in place. We can start pushing some of these wires back here to make room for other stuff. We have the main rail here hooked up. I'm not sure I like the way this is bending over, but let's hope for the best. Actually, what we can do is we can quickly just plug it in and see if we're getting the 12 volt into the board. Alright, so I'm going to turn this on. And I have my LEDs on the board coming on, so that's a good sign we're getting power to the board. Just going to turn this off again. We have a couple other wires already coming in from the hot end over here. One of them is the proximity sensor. From the wiring, we have the voltage coming in from the 12 voltage supply, the always on the board over here in the corner, and then we have it going to the end stop for the Z min. So we can connect this one and the 12 volt. Now this is wired so that it can only fit into one way, which is plus to plus, minus to minus. Alright, so we have that one wired in, and I'm going to push some of these wires back to make room for other things. Okay, we have the 5 volt for the always on fan that goes next to the 12 volt always on output on the board. Okay, there's that. We have the thermistor from the hot end, the white wire here, which measures the temperature, which goes into the temp 0 on the board. All right. We have the black thermistor wire coming from the bed, which goes to the temp bed on the board. Okay, there's that. What is left now is most of the motors. So we have the extruder motor coming in through here. So we have the E0, the extruder goes into the E0 right here. All right, there's that. And then we have the remaining wires for the X axis along with the end stop for the X axis. And at this point, I think it's becoming clear that I'm going to have to open up this cavity because this is not going to. Let's see. No. So what I'm going to do is I'm going to actually chip here, and it automatically breaks open. So don't worry about that. It goes with the line the way it was printed. And now we can kind of work this cable through like so. I still want to try to get them through this cavity to keep them all in place. We have the end stop for the X axis, so that goes to the X min. Over here. Okay, and then the actual motor connector goes to the X output next to the stepper driver here. All right, that is in. Okay, and then we have the Z wires coming from the motor. Goes again. I'm going to work these through. So the end stop goes to the Z min over here, and the motor goes to the Y. Okay. Ah, got it. All right, goes to the Y axis. All right. And then lastly, the Z motor. And it's only the Z motor. There's no end stop there because we're using the proximity sensor, which is inside the hot end. So lastly, okay, let's get this one. The Z worked through there. not pretty. I'm going to have to redesign this to be way bigger. And lastly, the Z motor goes through here and it goes into the output at the Z and stop. There we go. And except for the USB, or sorry, the LCD, which is here, we can put this one together. Remove the knob over here. This one again was designed to be able to be connected down to the board with 6mm. Actually, probably, let's say 8. The board is screwed into the container like this, and then we can add the turning knob. You can use the original one, or you can use the one that came with this printer. Either one will work fine. You're just going to make sure that you don't push out too far. You need to have this clicking motion. We have to take note that we have EXP2 and EXP1, and they have to correspond. Get the lid on here. And this was built, this case, to actually have receptacles for. Oh, there first. There we go. And then a simple 6mm screw in the back here will keep this closed. There's like receptacles for 6mm screws in the front as well. Minor overkill, but you know, why not? Oops. And one goes to, there we go, this is one. One goes in here. Again, there's only, should only be one way how this can fit in. And number 2 goes over in here. So there we have it. Everything wired up with the intent that I'd be able to move this out of the way even when the printer's connected. But so to get it in, we actually have to turn it over. However, before I do that, I am going to plug it in and see if we get anything. Or smoke, which would be the worst. There we go. Now we're getting an LCD. Marlin bugfix 20.x, which is what we installed when we actually did the wiring video. So I'm not going to insert it yet, but we are going to kind of see if we can get some things operating. Let's see, let's look at temperature. Actually, let's look at the current temperatures on the info screen. So we're showing 20 degrees and 20 degrees, which is good. That's the thermistors are working properly. I'm going to set the nozzle temperature to 210. Alright, let's see what happens on info screen. At this point we see the temperature going up for the nozzle, so that is working. We can do the same thing for temperature to test the bed. I'm going to set the bed to, let's say, 60 degrees Celsius. Let's go back to main and info, and we can see now that the temperature for the bed is rising. Alright, so temperatures are all working. far as motion is concerned, we can motion. Let's see, we're going to move axes. We're going to move X. We're going to move it 1 millimeter. And X, I hope you can capture this on the video, is moving. I'm going to try the Y axis. I'll try 1 millimeter first. And that is moving as well. We're going to try the Z axis, 1 millimeter at a time. Now clearly that needs to be configured, because right now when I do 1 millimeter it actually moves almost an entire centimeter, and that is, you know, in the configuration we are going to be setting the steps per unit, but it's confirmed that the axis moves. And that kind of covers it all except for testing the end stops. But I'm not going to do that until I've got everything configured, and I will hook up the pronter face in the next video. Final step, I'm going to turn this off. Final step will be to actually get this case into the printer. We're going to add a T-nut at this end of the case that will fit into the rail below here. And then we have 2 M3 screws that go through here that hook into the power unit, and the power unit has 2 little square nuts in there as receptacles for. This is going to get slightly challenging. We are going to have to flip this over, get this out of the way, flip this over and under. Move the bed forwards now and connect the T-nut in the back here. There we go. And here we have it, a fully assembled C3Dt/C. And in the next video, oh boy, oh no. In the next video, we will be going through the software to set it up properly. Let me again plug it in just to make sure everything is still connected, because we did move a bunch of wires while we were inserting this. Alright, so the on-off button below here. Alright, so everything is still seemingly running. There you have it. The full assembly of the C3Dt/C cantilever printer. Next video we will go through the setup of the software and upload all the right parameters. If you like this video, give me a thumbs up. If you really want to help me out, go to the Patreon link in the bottom. I'm doing all of this for free. I'm getting nothing to very little in return, so any little bit of help would really be appreciated. And thank you, and have a good day.